cosecant, secant theta, and cotangent. Now, when you're looking at angle theta, I have taught my students in the past to always draw them an arrow from that angle over to the other side, which would give them the opposite side, which is OPP. Then the angle here, which is angle theta, adjacent to it, which is right next door to the angle theta, is what I call the adjacent side, which is ADJ. So now let's look at the 6 trigonometric functions and the acronyms that go along with them. For sine theta, you have OPP over HYP. HYP is your hypotenuse, which is always going to be across from the right angle. Okay? Let's talk about it. Angle theta, across the street, OPP. Next door to angle theta, ADJ. Then right across from the right angle is your HYP. Any questions so far? Raise your hand if you have any questions. Now let's run it down. When I was a little girl, this is how I learned it. Sine theta, OPP over HYP. Cosine theta is ADJ over HYP. Make a little rhyme out of it. Then tangent is OPP over ADJ. Cosecant is the opposite, which is the inverse of sine, which we're just going to flip it. It'll be HYP over OPP. Secant is the inverse of cosine, which would be HYP over ADJ. And then cotangent is the opposite of tangent, which is ADJ over OPP. So you like to rap? Just get your little rapping going on, and then you can memorize the 6 trigonometric functions just like I showed you. Okay? Any questions for those who are absent? Any questions? Now, Ms. Hagler, you were absent. So in order for me to find my opposite side of this theta, angle theta, what's the very first thing I did? I drew my arrow to the other side, to the opposite side, which is the OPP. Then right next door would be your ADJ. Across from your right angle is your what? Hypotenuse. See how easy it is to learn that? Nothing hard about it. Any questions for those who are absent? How about you, Mr. Sanders? You know, I taught you in the 10th grade, right? Geometry. In geometry, we taught you the 6 trigonometric functions. Okay, so therefore, we're just reinforcing it in algebra 2 with trig. Just reteaching it back to you. Okay? Any questions for those who were absent? Okay. Now, for those who were absent, we had our unit circle. I got to redraw it again for you. We're going to divide this circle into 4 quadrants. Now, I've got my circle drawn. It's in 4 quadrants. This is on Mr. Tyree. Whatever you're doing, you need to stop and pay attention. Right here, you have a 90-degree angle. Ms. Hagler, right here, you have a 90-degree. Here, a 90-degree. And also here, 90 degrees. So that's 90 degrees. What do you think is going to be over here? 180, 180 degrees. Then we're going to add 270 degrees. And then all the way around, 360 degrees. What is the total degrees of a circle? 362 degrees. Okay? Got a question so far, baby? I'm trying to bring you guys up to where we are. Now, I taught them how to convert degrees to radians and radians to degrees. We used the example, we had 60 degrees, and on that paper we have our little formula. What's that formula?
Pi times
Times
pi.
pi. Pi radians over 180. 180 degrees. Now, what did I do with that 60 degrees in order to make it look just like that?
You multiply times pi.
I'm going to multiply, but I love dealing with fractions. So I decided I want to change this to a fraction by putting 60 over 1. And then I said my multiplication sign, for my purposes, I always enclose my multiplication sign in a circle to let me know that I'm multiplying. Okay? Now we're changing degrees, 60 degrees, to radians. Now, what's 60 times pi?
60 pi.
60 pi. And what's 1 times 180? 180. Okay, now can I reduce 160? 60 over 180?
Yes.
So what would it be?
Pi over 3 radians.
Pi over 3 radians. Okay? So for those who were not here, we have changed the degrees to radians. And by doing that, we have this equation, this formula. Pi radians over 180. Now, in order for me to change the radians to degrees, we're just going to do the inverse of this formula. So we found pi radians, pi over 3, times, and the inverse is 180 over pi. So now, tell me what would my answer be? I got pi radians over 180 times 180 over pi. Multiply your numerator first.
180 pi.
Very good. 180 pi over what?
3 pi.
3 pi. Now tell me what my answer would be. 60 degrees. Just trying to bring you up. You missed at least about 3 days of information. So I'm bringing you up to where we are. Come on, Miss Pincus, you had a question?
How did you get 180 pi and 3 pi? Because you
That's a question for me. You have your numerator up here, right? So 180 times pi equals 180 pi. 3 times pi is 3 pi. 3 into 180 goes how many times? And pi into pi crossed out because that's 1. Pi into pi goes how many times? 1. Okay, good question, Miss Pincus. Any more questions for those who were not here? For those who are not here. Okay, so you got this concept, right? You got that concept. Mr. Sanders, do I need to clarify anything else, baby? No. Okay. Now, what about the 6 trigonometric functions for those who are not here? Have you got this? Okay, I know you do, Sanders, because I taught you, baby. Now, let's just look at the sheet that I gave you, you two that were not here, dealing with measures and angles. Measures and angles. We have an initial angle and a terminal side. An initial side and a terminal side. Now read for me, Mr. Sanders. Okay. Now, what's the total revolutions equal? 1 revolution equals to how many degrees? 360 degrees. What about pi radians? How many degrees on there? Look at the sheet. A total of 180. Okay, now, what about 100 grade?
90.
90. Okay, I'm just talking to the people who were not here. The other ones, you have your sheet, finished working on the computations of those problems. But I'm looking at Mr. Sanders and Ms. Hagler. They were not here. So I'm just updating you, bring you up to speed. Okay, now, we're there, right? We're looking at this clock in front of us. That red hand is going to which direction? Okay? And then that's clockwise. That's negative. Now when it goes counterclockwise, it's going to the right, that's positive. Okay, I want you to keep that in your head. Clockwise, negative. Counterclockwise, positive. Now, look at the first question they asked you to do. 1 revolution equals how many degrees? 360. It says you're going to cross out the one that does not equal 360. So looking at that first row, which one did you cross out? Pi radians, because pi radians equals to what? 180. Very good. Very good. Now, any questions on how to complete that one? Any questions, Hagler? No questions, Sanders? Okay, let's flip it over. Woo! I'm on the roll. You on the roll? Okay. Now, let's look at arc length. Arc length. Ms. Hagler, read for me.
The linear measure S of an arc of a circle is related to the radial measure of its central angle, theta, and the radius r. S equals theta r.
Very good. S equals what?
Theta r.
Theta r. Okay, let me give you some clean. All right. I've been waiting on you two to come back so I can bring you up to speed with you. Y'all doing great though. Ms. Hagler, didn't I teach you in geometry? I know I did, baby. I remember my children. I remember who I teach. I taught you and Sandra, so you remember me teaching y'all about the 6 trigs? Wonderful.
Wow.
I was preparing you for myself. So I wouldn't have to teach so hard. Okay. Now, we've got S is equal to theta r. But before we can go any further, it told us we had to convert those degrees to radians, correct? Okay. So we have what, 45 degrees? 40 degrees? Let me see, baby. 40 degrees? I believe you. You know, I just have to see with my own eyes. You know. Okay. So we have 40 degrees. I want my purple back. Somebody changed on me.
Still black.
Still black, baby. There we go. I got to get that purple, you know, purple and white. Okay, now, I've got to change these degrees to radians. And what is that formula? Pi radians over 180 degrees. All right? So that gave us 40 pi radians over 180. Correct? So we need to reduce 40 over 180. What's my number that I can take to divide into 40, and also that same number can go into 180 and leave no remainder? What you say, baby? Well, let's just look at it. You got a 40 and you got 180. They end in that 0. So we can start with a 5. We can start with a 10. We can say 10 and going to 40. How many times? 4. Okay, let's just work with it until we work ourselves. 10 we're going to 180. 10 into 18 goes how many times? 1 time. 10 into 80 went 8 times. Oh, we got 4 over 18. Can I look at reducing some more? Yes, I can. So what I need to use? 2. 2 into 4 went how many times? And 2 into 18? So that means we have 2 over 9 pi radians. Okay, let me do a little abbreviation here. Okay, so we have 2 over 9 pi radians. Is that on that paper?
Hold on.
Okay. Now, what I need to do is to use this little piece of information, substitute it into my formula right here. What is the radius? What did it say the radius is? Right here. 18. Okay? So I got 2 pi radians times, I like to make that look like a fraction, 18 over 1, which represents the radius, which will give me my x. So what's 2 times 18? Sanders. What's 2 times 18? We got 2 pi times 18. 2 pi times 18. Okay? So you got to change that pi into a numerical number, which is 3.14 times 18 over 9. Give me a question. Okay? Give me a question. Now, of course, with your calculator, here we go. Since you don't want to work with your mind, I got me a calculator. Bringing it up. I got 2 times 3.14 times 18 equals. That gave me 113.04 divided by 9. They said S, therefore, is equal to 12 point, that's 56. But do we have some inches? Inches. Okay. There it is. That's how we would do the length arc. We find the arc of the length. The length of this arc, I'm sorry. Any questions? Let's look at another concept that you missed too, baby. Okay, here's something else that we went over while you were not here. Y'all got this? Hagler and Sanders? Okay. Well, I just love teaching the children that I taught. Because y'all remember. Okay? Work with me in my little beautiful triangle. See my beautiful triangle? It's a right triangle. I'm going to put A, B, and C. Okay? A, B, and C. And across from the right angle is Y, right? What's the hypotenuse? HYP. Across from my right angle is my HYP. Now, I want to deal with angle A. This angle A. So I'm going to put numbers here, 5, 4, and 3. Sanders and Hagler. 5 represents the hypotenuse. I got a 4 on this side, and I got a 3 on this side. What did I tell you to do? I'm dealing with angle A. How would I find my OPP?
How you find your OPP?
From angle A. I'm doing angle A. Not you. I'm talking to Mr. Sanders. He was not here. All the rest of you were here. I'm updating these two. Okay. How did I tell you? How did I find on there the theta? I drew the arrow. So from angle A, I'm going to draw me an arrow. Cross the street. So from angle A to find my OPP, I'm drawing an arrow, and that's the OPP. What is right next door? ADJ. Okay? ADJ, correct? So I got my OPP, my ADJ, and my HYP. And these are my numbers that represent. Let's find, now we're talking about sine A is equal to OPP over HYP. What number represents Sanders? Come on, baby, up. If you want to sit right here, come on up. What number represents OPP? 3. I'm plugging it in. Plug it in, plug it in. What number represent HYP? 5. Plug it in. That is sine A. Now let's look at cosine A. Cosine A, what's the acronym for cosine? Very good. ADJ over HYP. Let's plug the numbers in. What represent ADJ? 4. And of course, did the hypotenuse change?
No.
Stayed the same. Now let's look at tangent A. Sanders. What's my tangent A acronym? OPP over ADJ. OPP over ADJ. Move up if you need to see, Mr. Sanders. Come on, baby, work with me. So what number represents OPP? 3. And what is the ADJ?
4.
What about cosecant A? What's the acronym? Very good. HYP, just the inverse over OPP. And give me my numbers. What's the number? 5 over 3. That's what I'm talking about. I've been missing you. I've been missing you. And secant A, Sanders, you settle down there?